to keep the background noise to a minimal. If anyone has any questions, we will have a question period after the presentation before ending the meeting. Today, we're going to review the set points and capacity screens. We're going to look at 4 screens today: the set points page, other set points page, the capacity page, and the VFD capacity page. One quick note to keep in mind before we move on is, depending on the panel's program configuration, some of the items we discuss will not be available on all panels, such as VFD capacity and features we will discuss in other set points. Again, this is due to program configuration. One other quick note, we have acronyms throughout the panel that we get asked often about, and I just want to point out the tool that we have built in, located in the operating values header. We have an info button. By touching this window, we'll open the complete list of all the acronyms found in the operating values window. However, you may still find others throughout the panel that are not in this list. We are trying to get this tool added in anywhere you'll find acronyms for a future update. So let's get started. First, we need to access the menu. We can do this by simply touching the menu button at the bottom of both screens. The menu screen will open. We want to access the set points. However, there is a lock over the icon, indicating that the user cannot access without proper security. In addition to the locks on the icons, the username field will indicate the active security level. Sorry. The MYPRO Touch controller contains 3 levels of security and has default usernames and passwords. Here are the security levels and the access granted with each. This table details the features that each security level has access to. Level 0, located here, has access to monitoring logs and trends. Level 1 has access to level 0 as well as operational parameters. And level 2 has access to level 0 and level 1 as well as configuration and management of the controller. The set points that we are discussing today may be accessed using level 1. To change the security level, select the username field on the top center of the screen. You do not have to close any screens to access security changes. The login window will appear as shown. Press the down arrow to open the username list and select ABC. Then click the password field. For level 1, click ABC and enter password 1111. If level 2 password is preferred, enter 2222. With the username and password correctly entered, the locks will disappear from the menu screen. From here, we can see the menu has 2 pages, menu 1 and menu 2. The 4 pages we will be talking about today are found on menu 1. Let's begin with set points by touching the set points icon found in the top left corner. Here we have the full set points page. We have a lot on this page to go over, so let's break it down into the 4 windows we have. And from here, let's start with the set points window, as it contains the main parameters we always want to know when talking about a system. What is our control pressure, and what is the acceptable operating window? We have 4 groups of set points that we can adjust here. In each set point group, we have a cut-in, which is the value that will start the compressor if the pressure climbs above. We have a cut-out, being the value that will stop the compressor if the pressure falls below. And we have our control target, which in this case is local suction pressure. This control could also be based on system suction pressure, chiller leaving temp, local discharge pressure, system discharge pressure, a combination local suction pressure and leaving brine temp, or a combination system suction pressure and leaving brine temp. The cut-in and cut-out are only active if the operation mode is selected to auto start stop yes. This can be checked or changed by going to menu 1, then select controls from the top row, then check or click the status and touch the combo box to select yes or no. Selecting no will make the compressor only turn on via a start command and off with a stop command or the failure limits. Now going back to our focus of the set points window, and if we add the current control settings window into view, we can now see where we have the ability to switch our active cut-in and cut-out and our active control target set point. If we touch the cut-in, cut-out combo box, we get a selection dialog that allows us to change between set point 1, 2, 3, 4, the scheduler, or COM. These last 2 we will cover in a future webinar. If we select set point 2, we will see the orange highlight that was on set point 1 has moved to set point 2. This is a confirmation that our selection has been accepted and a quick visual of what the active selection is. So now you will notice our control target is still set point 1. We can change that by selecting the appropriate combo box. And just before we select the set point, before we select set point 2, I want to point out a feature we have on the MYPRO Touch Plus. If you notice these colored lines under the set points, these show the color assigned to each target set point. You can assign these colors by clicking menu 1, select display settings from the bottom row, then check the color of choice for each set point. But what do these colors do? If we go back to the set point page and select set point 2, you will see the target has switched to set point 2, and more noticeably is the headers have changed to the assigned color as well. This applies to all screens and is intended for customer customization and to see as a tool for quick visualization of the selected set point. For instance, set point 1 being red could be assigned to process shift, while set point 2, maybe blue, being a weekend shift. How about set point 3, maybe green, a maintenance shift? Or how about a swing machine? Set point 1 being a low stage, set point 2 being high stage. When an operator walks by, he can quickly see, based on header color, what active set point and therefore what system that machine is set up to run on. That's it for target for now. Next, we'll take a look at the system window. The system window is mainly timers dealing with starting and stopping the system. Let's explain this by using a start sequence. First, we need a start command, either a local start button, remote start, or communication start. This will activate the start delay timer. Once this is complete, the panel checks to verify the process value is greater than the cut-in value. If this is true, the cut-in delay timer times, and once complete, the oil pump delay timer is activated. Once this timer has completed, the oil pump will start. Once the oil pump is running and we have sufficient oil pressure, the compressor start delay timer times. And once this timer is complete, we get our compressor start signal. Now let's look at the shutdown settings. The cutout delay is the amount of time the process value needs to be less than the cutout before the system will start the shutdown sequence. Cutout LSV percent is the percentage the compressor wants to achieve prior to shutting down. If a failure occurs due to the slide valve not unloading to 5% quickly enough prior to startup, to allow excess oil to drain out of the compressor body, compressor restart delay timer will need to expire before attempting to restart. If the oil pump runs while the compressor is off, for more than the over lube confirm timer, the interval time will count down to again allow for oil drainage. The next two items work closely together, as auto unload max time and clear ready to start capacity are designed to unload the slide valve after a failure is cleared. The oil pump and the unload solenoid can automatically turn on for a maximum time of the value entered, and will try to unload within this time to under the slide valve percentage entered, here being 60 seconds and 20%. The oil feed delay is a control timer of oil feed solenoid that, after MSRB, or motor starter readback, goes true. If full lube is selected, the output will turn on. If pre-lube is selected, the output turns off. The last two items are lag oil pump settings that are only utilized if you have a 2 oil pump setup. And the explanations are listed here, and more detail can be found in the manual. Next, we'll look at the pump out window. Capacity 0% stop, set to yes, will require the compressor to fully unload the slide valve below a fixed 5% prior to shutting down when a stop command is received. The minimum and maximum delay are the amount of time pump out will operate within. Pump out pressure is the desired pressure the compressor is to achieve to complete pump out before shutting down. Pump out percent is the percentage the compressor is to operate at during the pump out sequence. Once pump out starts, capacity lock delay timer needs to expire before pump out percent is locked in. The residual operation timer is the amount of time the compressor or oil pump will continue to run after pump out has completed to try to unload the slide valve to 5%. If capacity 0% stop is selected as no, the compressor will turn off and the oil pump will continue to run for the residual operation. Where if yes is selected, the compressor will continue to run for the residual operation time. And once complete, the oil pump will continue to run for the oil pump stop delay time before shutting down. That wraps up the set point page. Next, we'll take a look at the other set points, again found on the top row of menu 1. Here we can see the other set points page is divided into 9 windows. We'll start with the left column of the screen. The AntiCycle time window is where the motor and starter protection timers can be adjusted. The AntiCycle time is the minimum time between starts. The interval time is the minimum time between the last stop until the next start. For example, if we use the settings shown, if the package is started and cycles off on low suction after 300 seconds of running time, it will not be able to start for 600 more seconds due to the AntiCycle. On the flip side, if the package runs for 24 hours and cycles off on low suction, and after it stops, the suction pressure spikes above set point, the package can start after only 10 seconds because the AntiCycle has expired. Another example of the compressor running for 5 minutes and stops. The interval time triggers when the compressor stops. The compressor cannot restart until the AntiCycle time is complete. The oil drain solenoid option is typically enabled for the suction case drains on the compound compressors. It energizes, depending on configuration, right after the oil pump stops, and de-energizes after the time set in the SV off delay field. Hot gas bypass solenoid option is enabled in system configuration, page 2. The control contains 2 different methods of operation. First, the low stage capacity is compared to the 3 top parameters. The SV on-off low stage slide valve percentage and SV on delay. Set the delay before the hot gas bypass solenoid valve turns on after the low stage capacity has reached the set value. The second operation is the hot gas bypass solenoid valve turns on at the set suction pressure once the on delay timer has expired. The compressor oil seal protection feature is active from system configuration page 2. The feature provides intermittent operation of the oil pump. Seal protection functions include interval, select enable to activate the intermittent operation of the oil pump parameters. The start period, set the interval of the oil pump intermittent operation. This takes place when the compressor has been off for longer than the entered value. Oil pump run is the total time for the oil pump to run for each interval. Compressor stop, if enabled, this is to allow the seal protection to operate if the compressor in auto start stop is yes, and the compressor has stopped due to cut out and is in standby. If disabled, seal protection will only function if there is no start command present. Oil pump delay is active when compressor stop is enabled. When the compressor is stopped, the oil pump will run for the duration of the setting. Now let's take a look at the right side of other set points. The oil heater set points control the oil heater based on oil separator temperature. If there is no temp sensor in the oil separator, the oil heater will have an integrated thermostat within itself. As long as there is a temp sensor installed, the panel will have the following settings: the temperature off and the temperature on set points. The heater off setting must be higher than the heater on setting. Starting bypass, excuse me, sorry. Starting bypass solenoid option. This feature is activated by selecting the appropriate bypass option in the system configuration. Starting bypass or starting bypass DP from the drop-down menu. The set points include the starting bypass. The set points included for the starting bypass are SV off delay starting is used during initial starting of the compressor. When the compressor starts, the solenoid output will energize and remain energized until the SV off delay is complete. SV off delay stopping is used when the compressor is stopping. The solenoid will energize for the duration of the timer when the compressor stops. SV on DP and SV off DP are not active with the starting bypass option and are active with the starting bypass DP option. When selecting starting bypass DP option from the drop-down menu, the set points included are SV off delay starting time, prevents discharge pressure control during initial starting of the compressor. SV off delay stopping time prevents discharge pressure control when the compressor stops. SV on DP is the pressure setting to energize the starting bypass solenoid. This value must be greater than the SV off DP setting. SV off DP is the pressure setting to de-energize the starting bypass solenoid. Oil pump start delta pressure set points are used with oil pump feed type selected as auto lube. The first parameter for this feature is the start suction pressure. This value is fixed by the controller. The oil pump will start when the suction pressure is greater than or equal to the start suction pressure value for a fixed 6 seconds. The stop SP value is also fixed by the controller. The oil pump will stop when the suction pressure is less than or equal to the stop SP value for a fixed 5 minutes. The start delta pressure adjustable set point starts the oil pump when the differential pressure is less than or equal to the start delta pressure value for a fixed 6 seconds. The stop delta pressure value is also adjustable. The oil pump will stop when the differential pressure is greater than or equal to the stop delta pressure value for a fixed 5 minutes. The oil return solenoid set points are active when the oil solenoid valve option is set to use on page 2 of the system configuration. The first parameter for this feature is the open delay. This is an adjustable time delay to energize the oil return solenoid when the compressor starts. The next setting is the close delay. This is another adjustable time delay to de-energize the oil return solenoid when the compressor stops. Evaporator oil return is enabled on page 5 of the system configuration. Understanding there is various types of piping styles for oil return, there are numerous optional control applications. These include criteria such as number of solenoid valves, motorized valves, also commonly called electrically actuated valves, and level switches or float switches with direct acting or reverse acting control in any combination. Evaporator oil return parameters include the following. Mask time. This is the time delay after the compressor starts before the oil return control is active. Level switch delay is available when oil return option includes level switch or float level switch. This time entry is the period that the level switch closes or opens the controller's digital input to activate oil return. Interval time is the time delay or interval that the oil return control is inactive. And control time is the time delay or period that the oil return control is active. This wraps up all 9 windows within the other set points page. Now we're going to move on to the capacity PID low stage page, found in the second row of menu 1. Here we have the capacity control page. We have 3 windows to go over. In the monitor window, we have the process variable at the top. This is the value we are trying to control or process. We have the control set point, which is the target we want to process. We want the process value to get to. We have the PID out, being the panel's calculation of slide valve percent to correct the error between the process value and control value. We have the slide valve percentage. And at the bottom, we have the operational mode selection. The operation combo box allows you to select the PID operation mode. Here we have set up for manual mode. that allows the operator to load and unload the system with the increase and decrease buttons. These buttons only function while you are touching the button. Release the button and the slide valve will remain where it is until you touch the increase or decrease buttons or switch out of manual operation. When we switch out of manual operation, the increase and decrease buttons are hidden. The other options we have from operation mode are auto, which the panel calculates the slide valve position with the PID control. We have remote digital, which utilizes 2 digital inputs. We have remote analog, which uses one of the spare analog input channels and can control either the slide valve, or if you have VFD control set up, it will control the VFD and the slide valve will load automatically. We have COM, which is for an overview system controller. Remote analog 2, which is the slide valve and VFD control from one analog input. And we have COM analog 2, which is, again, slide valve and VFD control from one communication register. PID is an acronym for proportional band, integral, and derivative. This control action allows a measurement or process variable to be controlled at a desired set point by continuously adjusting a control output. These control parameters act on the error or deviation between set point and process variable, in this case, suction pressure. Let's review the parameters of the PID control. First, we have deadband. It is the temperature or pressure range added above and below the target value. That is the buffer zone where adjustment to outputs is paused to prevent excessive load and unload pulses. Proportional band affects the controller output changes in ratio to the error difference between suction pressure and the control set point. A smaller number creates a more aggressive output, causing the controller to overshoot. A larger number will adjust in smaller increments, allowing it to reach set point over a longer period of time. Integral time accounts for past values of the set point minus suction pressure error and integrates them over time to produce the I term. Again, a smaller number creates a more aggressive output, causing the controller to overshoot, and a larger number will adjust in smaller increments, allowing it to reach set point over a longer period of time. Derivative time is a best estimate of the future trend of the set point minus suction pressure error based on its current rate of change. It acts as an anticipator control, effectively seeking to reduce the error. Smaller number is more aggressive, and larger adjusts in smaller increments. Manual reset is a percentage entry of the slide valve. When the integral time and derivative time are both set to 0, and the error between the suction pressure and the control set point are equal to 0, the PID controller uses this value as the PID out percentage. The output change rate is the changing rate of percent per second of the PID output. This is the amount the controller could potentially move the slide valve in 1 second. This is default 100% and should be adjusted to a lower percentage, as this will allow the slide valve to move from 0 to 100% or from 100% to 0 in the percentage and time that is set here. The next section of parameters are the capacity limits. These settings protect the compressors and motor from reaching critical conditions that may cause damage. Each type of capacity limiter has 2 entry fields to overwrite the PID or capacity control and communications: unload and load forbid. These limiters override any other signal to prevent damage to the compressor and motor. The first 2 entries protect the compressor motor. High MA unload limiter and high MA load forbid limiter interrupt the capacity load signals when the current is greater than the setting. In our example, if the motor current is greater than 80 amps, the high MA load forbid limiter prevents a load signal from being performed. If the motor current increases to or above 90 amps, the high MA unload limiter forces the slide valve to unload to reduce the work the compressor is doing, and thus reducing motor amps. Next, high DP unload limiter and high DP load forbid entries. These parameters are compared to the compressor discharge pressure. When the pressure exceeds these load forbid settings, the compressor will no longer receive load signals. When the pressure exceeds the unload limit, the compressor will receive unload signals. If you have a compound compressor you are operating, the high IP unload and load forbid limits for intermediate pressure will be available. The low SP unload and low SP load forbid entries are compared to the compressor suction pressure to unload the compressor and prohibit load signals to the compressor during a low suction pressure condition. The parameters for capacity control are as follows. Control start delay. This time entry is the delay from when the compressor starts until the capacity control operation begins. PID output deadband. This entry eliminates changes to the slide valve position until the change exceeds plus or minus the percentage value. This value is small, however, too small of a value shortens the life cycle of the digital outputs and solenoids. The force load ratio entry is used for forced capacity loading with communications or 100% block. We have ramp control. This is to limit the load rate of the slide valve during startup. Once all step timers have expired, the ramp control is disabled until the compressor is started again. In ramp time 1, we have 30 seconds for all of our step timers. The percentages listed beside them are the percent of slide valve that is maintained or limited to until the step timer has expired. The MVL percent is the minimal operational slide valve percentage, and the MVH is the maximum slide valve operation percent. This is everything for capacity control. Next, we'll move on to the VFD capacity control. The VFD capacity control is very similar to the slide valve capacity control, and I'm only going to go over the additions or differences. In addition to the three similar windows being monitor, ramp control, and set points, we also have an output limit window in the VFD capacity control. VFD ramp control works the same as the capacity control ramp control. The VFD ramp timers are active after the capacity control timers expire and after the slide valve is at 100%. The PID set points for the VFD are like the capacity control parameters. The parameters include settings for speed increase and decrease to maintain the suction pressure or other control variables selected. The limit entries are mainly used for overload protection. The last four entries are different from slide valve capacity control. There are two delays for the VFD control start and control stop. The control start delay is the time value between the compressor slide valve capacity control and, the slide valve capacity control ending and motor speed control starting. The control stop delay is the time value between motor speed control stopping and compressor slide valve capacity control resuming. The last parameters are the rate of change when a full speed increase or decrease signal occurs. The force load and unload parameters are dependent on the operation mode. With remote digital operation, the force load and unload are triggered by the remote load and unload digital inputs. Otherwise, the force load is active based on communications set, and the force unload is active based on exceeding the VFD limit setting. Next, we'll take a look at the output limits. Output limit zones are available for frequency or RPM skips or jumps. This is to help eliminate vibration in the compressor. If we have excessive vibration at 46 to 47% speed, and then again at 61 to 65% speed, and any other percentage, we could have up to 3 zones to skip these high vibration speeds. With zone 1 low set to 45% and zone 1 high 48%, the PID out percent will continue to climb through this zone. However, the real output to VFD percent will show the output is paused at 45% until the PID percent climbs above zone 1 high setting of 48%. Once this occurs, the output will skip or jump to match the PID out. This is the same operation for zone 2 and zone 3 if utilized. One other quick note, the zones do need to be programmed in sequential order. So the highest percentage must be in zone 3, the lowest percent must be in zone 1. This wraps up the VFD capacity, and that wraps up our webinar for today. We're planning to have our next webinar on communication setup and basic communication troubleshooting. Keep an eye out for your invitation for this webinar. At this time, I'd like to open it up for questions. You can either unmute yourself, raise your hand,